On the evening of June 24th, 2026, the ground under northern Venezuela moved twice. A magnitude 7.2 earthquake struck first about 100 miles west of Caracas. 39 seconds later, a magnitude 7.5 earthquake struck almost the same spot. If reports like this one are useful to you, subscribing helps you find the next one. More than 3,800 deaths are now confirmed. More than 16,000 people are injured, and tens of thousands are still unaccounted for. The satellites found something the first models missed. Images taken before and after the shaking show that the fault broke the surface on dry land near Maiquetía, at the edge of the capital, moving the ground sideways by more than 10 feet. That kind of offset does not just shake a building, it pulls the ground out from under it. This report walks through the evening it happened, the fault that carries the strain, what the measurements say now, the landslides and the water and the sickness that followed, and what remains uncertain. The holiday that fills the Venezuelan calendar in late June marks a battle fought in 1821 at Carabobo, the one that settled the country's independence. It is a day off. Offices close, schools are already out, and the buses run light. That detail matters more than it sounds, because it changed where people were standing when the ground moved. Most of them were where they live. They were in apartment towers and cinder block houses, in kitchens and stairwells and back rooms, rather than in the office buildings and factories that empty out at night anyway. The evening was ordinary. In the north of the country, 6 o'clock in June is the soft part of the day, after the worst of the heat and before full dark. The light was going. Along the Caribbean coast, the sea was doing what it does. Picture the shape of the land, because the shape explains a great deal of what followed. Venezuela's northern edge is a wall of green mountain running east and west, close enough to the water that in places there is barely a mile of flat ground between the slope and the surf. That narrow shelf holds the state of La Guaira, and on it sit the country's main international airport, its main seaport, and a chain of coastal towns pressed between the rock and the waves. On the far side of that same wall, tucked into a long valley about 3,000 feet up, is Caracas. Something like 5 million people live in and around the capital. The mountain separates the city from its own coastline. A highway and a tunnel carry everything between them. West of Caracas, the coastal range keeps going, past the industrial town of Moron, past the sugar country of Yaracuy State, toward the city of San Felipe. This is farmland and small towns. It is not the part of Venezuela that appears in the news. On a map, it looks unremarkable. 100 miles of green hills between the capital and nowhere in particular. Underneath it, 2 enormous cracks in the crust come together. Nobody in those towns was thinking about that. Nobody had reason to. The last time this exact stretch of ground produced a truly destructive earthquake, no one alive had been born. In the previous 100 years, only 7 earthquakes of magnitude, 6 or larger, had occurred anywhere within about 150 miles of the spot. That is a quiet record for a plate boundary. Quiet does not mean safe. It usually means the opposite, because a fault that is not moving in small increments is a fault that is storing what it owes. There had been a warning of a kind, though not one that named a day. The previous September, 2 moderate earthquakes struck to the southwest, one of magnitude 6.2 and one of magnitude 6.3. They killed at least 1 person, injured more than 110, and damaged buildings across the states of Zulia and Lara. Geologists noticed, in the ordinary way of these things, most people did not, and there had been a longer memory, further off. In 1967, a magnitude 6.6 earthquake, centered about 80 miles east of here, shook Caracas hard enough to bring down apartment towers and kill roughly 240 people. That one is still taught in Venezuelan engineering schools. It changed the building code. It also happened almost 60 years ago, which in a city that has grown informally and fast ever since is a long time for a lesson to hold. So the evening was ordinary and the ground was not. At 4 minutes and 33 seconds past 6, local time, the crust beneath Yaracuy State let go. The break did not start under Caracas. It started roughly 100 miles west of the capital, out where the hills are quiet, about 13 miles down. People in San Felipe felt it first, as a jolt and then a heave. In Caracas, a few seconds later, the shaking arrived as a long, slow roll, the way distant earthquakes usually announce themselves, and the lights swung, and people began moving toward doors. What happened next is the part that separates this event from almost every other earthquake the country has recorded. The shaking did not fade. It stopped briefly, and then it started again, and the second time it was worse. The pause lasted 39 seconds. That is long enough to stand up. It is long enough to get a child off the floor, to reach a doorway, to look around, and decide the worst is over. Across northern Venezuela, in the space of a little over half a minute, hundreds of thousands of people made exactly that judgment, and it was reasonable, and it was wrong. At 5 minutes and 11 seconds past 6, a second earthquake broke almost the same piece of ground. It was larger. The first measured magnitude 7.2, the second measured magnitude 7.5. Those two numbers look close together. They are not. The magnitude scale does not count feet or inches. It counts energy, and it counts it in a way that compresses enormous differences into small-looking gaps. Every increase of one full step corresponds to about 32 times more energy released. A 3/10 difference from 7.2 to 7.5 means the second earthquake put out close to 3 times the energy of the first. The first earthquake, on its own, would have been the most damaging Venezuelan earthquake in more than half a century. It was the smaller of the two. Seismologists have a term for this pattern. They call it a doublet. It means two earthquakes of similar size, very close together in time and in place, with waveforms that look almost like copies of each other on the instruments. Doublets are uncommon. Most large earthquakes are followed by aftershocks, which are smaller by a wide margin. A doublet is something else. It is two full-sized events, and the second one is not obviously the child of the first. The plainest explanation is that the first rupture handed the second one a push. When a fault slips, it does not simply relieve strain. It moves strain around. Rock that was being squeezed from one direction is suddenly squeezed from another. On a fault sitting nearby, already loaded close to its limit, that change can be the last small thing. Researchers looking at this pair believe something along those lines occurred. The two breaks happened within a few miles of one another, on separate faults inside the same tangled system, and the shaking from the first appears to have raised the stress on the second until it failed. The second fault was shallower. Its break began about 6 miles below the surface, where the first had begun about 13 miles down. Shallow matters. Energy released close to the surface has less rock to travel through and less distance to spread out before it reaches the buildings on top. A shallow magnitude 7.5 is a far more violent thing at ground level than a deep one. Both epicenters lay in Veros municipality, in Yaracuy State, west of the city of San Felipe and southeast of a town called Umare. They were separated by roughly 6 miles of ground. For anyone standing on the surface, the distinction between the two events barely existed. What people experienced was one long assault with a gap in the middle. Buildings that survived the first shaking were already cracked, already loosened, already carrying damage in the joints, and columns nobody could see. Then the larger one arrived and pushed them the rest of the way. Structural engineers have a plain word for this. They call it cumulative damage, and it is the reason a second shock of the same size does far more harm than the first. The shaking travelled. It was felt across Venezuela, from the Andes to the eastern plains. It reached Puerto Rico. It reached the Dominican Republic, more than 500 miles away, across open water, strongly enough that people there reported it, and news outlets asked what had happened. A tsunami alert went out within minutes, because a large, shallow earthquake near a coastline always earns one. It was cancelled a short time later. The fault here moves sideways rather than up and down, and a fault that slides horizontally does not lift the seafloor, and water that is not lifted does not become a wave. No damaging tsunami was generated. That is one of the few pieces of good news in this entire account, and it is worth saying clearly before the rest of it. By 6:15 in the evening, the dust was rising off the coastal range. The power was out across large districts of the capital, and the telephone networks were failing under the load. Nobody yet knew what had happened, only that something enormous had. The instruments knew. 200 miles away and 5,000 miles away, seismometers had already written it down. Within about 20 minutes, the United States Geological Survey had published preliminary numbers, and within a few hours, those numbers had been reviewed and settled. The first earthquake occurred at 4 minutes and 33 seconds past 10 in the evening, Coordinated Universal Time, which is 6:04 in Venezuela. Magnitude 7.2. Depth about 14 miles. Its epicenter was placed about 15 miles east-northeast of San Felipe. The second occurred at 5 minutes and 11 seconds past 10, Coordinated Universal Time. Magnitude 7.5. Depth about 6 miles. Its epicenter was placed roughly 12 to 17 miles southeast of Guaira, depending on which revision you read. Latitude 10.5 degrees north, longitude 68.5 degrees west. Those small disagreements between early reports are worth understanding rather than dismissing. When two earthquakes overlap this closely, their seismic waves arrive at every station on Earth mixed together. Separating them is genuinely difficult work. The magnitude of the first event was initially reported as 7.1 and later revised to 7.2. The depth of the first was given as 20.3 kilometers by some agencies and 21.9 by others, a difference of about a mile. None of this is error in any embarrassing sense. It is what precision looks like while it is still being assembled. Magnitude itself deserves a plain handle. The number reported for large earthquakes is called moment magnitude, and it is built from three things multiplied together: how much fault area broke, how far the two sides slid past each other, and how stiff the rock is. That product is the seismic moment, the total work the earthquake did. Moment magnitude is just that number, squeezed onto a scale that runs in single digits, so people can say it out loud. This matters because it means magnitude is not a description of shaking. It is a description of the earthquake. Shaking is what you feel, and shaking depends on where you are, what you are standing on, and what you are standing in. For that, seismologists use a different measure entirely, called intensity, written on a scale of Roman numerals. It runs from barely noticed at the bottom to total destruction at the top. Intensity is assessed from what actually happened at a place, not from what the fault did. The estimated intensity maps published for these two earthquakes show a long band of severe and violent shaking stretching from Yaracuy State east along the coastal range, brushing the northern edge of the Caracas Valley and covering the coastal strip beyond it. That band is not a circle around the epicenter. It is a smear running eastward. Hold that thought. Both earthquakes were shallow, and both were what geologists call strike-slip events. In a strike-slip earthquake, the two blocks of rock grind past each other sideways, like two hands sliding in opposite directions, with the palms pressed together. Nothing goes up, nothing goes down, everything goes sideways. This particular boundary is right lateral, meaning that if you stood on one side and looked across the fault the far side would have jumped to your right. That is not a curiosity of description. It tells you which way the ground moved under every road, pipe, and foundation that crossed the break. The main shock, the magnitude 7.5, was the strongest earthquake recorded in Venezuela since 1900, when an earthquake known as San Narciso struck the same general region. That is 126 years. No system in the country, not the water mains, not the housing stock, not the emergency services, had ever been tested at this level. The Venezuelan National Seismic Network, run by the Venezuelan Foundation for Seismological Research, has its national observatory in eastern Caracas. Its instruments recorded the sequence from directly on top of it. Its staff that night were in a building being shaken by the thing they were measuring. By midnight, the world's monitoring agencies had converged on the essentials. 2 large, shallow strike-slip earthquakes, 39 seconds apart, near the boundary between 2 of the planet's major tectonic plates. What they had not yet worked out was how far the break had run, or in which direction it had gone. When that answer came, it explained everything about which towns were destroyed and which ones were merely frightened. Before that, it helps to understand what was down there in the first place. Northern Venezuela sits on a seam. To the north lies the Caribbean plate, a slab of crust carrying the sea and the island arc beyond it. To the south lies the South American plate, carrying the continent. They are not colliding head-on, and they are not pulling apart. They are sliding past each other, the Caribbean moving east relative to South America, at a rate of about 0.4 of an inch a year. 0.4 of an inch a year sounds like nothing. It is roughly the speed at which a fingernail grows. Over a century it comes to about 3 feet. Over 2 centuries, 6. If that motion happened smoothly, nobody would ever notice. It does not happen smoothly. The rock along the seam is locked together by friction, so the 2 plates bend and store the strain, like a steel spring being slowly wound. The strain accumulates for decades or centuries. Then in 10 or 20 seconds, the friction is overcome, and the rock snaps to where it should have been all along. Everything that was stored comes out at once. The seam here is not a single clean line. It is a braid, a zone perhaps 60 miles wide, where the motion is shared among several faults running roughly parallel. Geologists call the whole thing the Boconó, San Sebastián, and El Pilar fault system. It stretches for more than 800 miles, from the Venezuelan Andes in the southwest, along the northern coast, and out to the island of Trinidad in the east. Each strand has its own name and its own history. The Boconó fault runs northeast through the Andes and the western mountains. Its last great rupture was in 1812, in an earthquake that destroyed Caracas and Mérida and killed a large share of the population of both. That was 214 years ago. At 0.4 of an inch a year, the Boconó has since accumulated something close to 7 feet of unpaid motion. Before this year, published assessments concluded that the accumulated deficit was enough to produce an earthquake somewhere between magnitude 7.0 and magnitude 7.6. The San Sebastián fault picks up where the Boconó bends east. It runs mostly offshore, a few miles out to sea, parallel to the coastal range and to Caracas beyond it. A short onshore piece of it passes near the country's main international airport, where it carries a separate local name, the Bruscas Fault. Mackle Higgins, a geophysicist at Florida International University, had published the assessment that the San Sebastián was capable of producing a magnitude 7.1. Farther east, the El Pilar Fault carries the same motion out toward Trinidad, separated from the San Sebastián by a pulled-apart basin beneath the Gulf of Cariaco. Read that back and something uncomfortable surfaces. The 2 faults that scientists had specifically named as likely sources of a future large earthquake in northern Venezuela were the Boconó and the San Sebastián. Those are the 2 faults that broke. This was not a prediction. Nobody knew the year, the month, or the day, and nobody claimed to. Earthquake forecasting works in probabilities across decades, not in warnings across hours. What the science had done was mark the place and estimate the size. It got both approximately right, and the estimate for the San Sebastian, magnitude 7.1, turned out to be low. There is a reason the population sits exactly here. Fault zones make valleys. Ground that has been crushed and ground up for millions of years erodes faster than the rock around it. So faults become the low places, and low places collect water and soil, and roads and people. Caracas is in a valley. The valley is there because the crust is broken underneath it. That is the arrangement across most of the seismically active world. It is not carelessness. It is geography, working the only way it can. What made the arrangement dangerous in Venezuela was not the fault. It was the 126 quiet years, the housing built during them, and the fact that the strain kept accumulating the entire time, at 0.4 of an inch a year, without pause while the country got on with other things. On the evening of the holiday, the spring finished unwinding. Where it unwound first was not, it turns out, where it did the most damage. An earthquake is not a point, it is a tear. Maps show earthquakes as dots, and the dot is the epicenter, which is only the place on the surface directly above where the break began. For a small earthquake, the tear is a few hundred feet long, and the dot is a fair summary. For a magnitude 7.5, the tear is enormous, and the dot tells you almost nothing about who gets hurt. The way to picture it is a zipper. The fault is a great sheet of rock, standing on edge, buried in the crust. The break starts at one point on that sheet, and then races outward across it, unzipping the friction that had held the two sides together. Behind the zipper, the rock has slipped. Ahead of it, the rock is still locked. The zipper travels at roughly 2 miles a second. For the main shock, the finite fault models built from seismic and satellite data show a tear about 110 miles long and 12 miles deep. That is the sheet of rock that came unstuck, and the zipper ran in one direction only. It started at the onshore epicenter in Yaracuy State, and it went east, toward Moron, toward the coast, then offshore onto the San Sebastian fault, and along it, parallel to the shoreline, in the direction of Caracas and La Guaira. This is called unilateral rupture, and it is the single most important fact in this report. When a rupture travels, it carries its energy with it. Every point along the tear radiates seismic waves, and if the tear is moving east at 2 miles a second, the waves it made a moment ago are still travelling east too. They stack up. Energy released at the beginning of the rupture, and energy released at the end, arrive at an eastern town, almost together, piled into one violent pulse. Behind the rupture, to the west, the same energy arrives spread out over a longer time, weaker at every instant. Seismologists call this directivity. The plainest comparison is the sound of a siren. An ambulance coming toward you compresses its sound into a higher, harder note. Going away, the note stretches and softens. The earthquake did that with shaking. So the epicenter was west, in farm country. The violence went east, along the coastal range, and struck the two most densely built places in the country. The finite fault model puts the largest slip, the place where the two sides moved farthest past each other, somewhere in the eastern half of the rupture. The United States Geological Survey model shows a peak of about 6.5 feet near the middle. An independent model built by Italy's National Institute of Geophysics and Vulcanology shows a considerably larger peak, close to 12 feet, and places it near Caracas. Those two models disagree, and the disagreement is honest rather than embarrassing. Most of the fault is under the sea. Satellites measure ground movement by comparing images of the surface, and the surface out there is water. The models can see where the fault came ashore and where it went out, and they must infer the rest. What both agree on is the direction and the length. The break ran east for 110 miles, gathering its energy as it went, and delivered it to the coast. Everything downstream follows from that. La Guaira was not the epicenter. La Guaira was where the zipper was still running fast and hard when it passed under the town. Caracas was not the epicenter either. Caracas is a city of 5 million in a sediment-filled valley, standing at the eastern end of a 110-mile tear, receiving a pulse that had been building for a minute and a half. Within an hour, an automated system in the United States looked at the magnitude, the depth, the location, and a database of how Venezuelan buildings behave, and issued a color. The color was red. The system is called the Prompt Assessment of Global Earthquakes for Response. It runs automatically. It does not wait for anyone on the ground to report anything, which is the point, because the places that most need help are the places least able to call for it. What it does is straightforward in principle. It takes the earthquake's size and location, calculates how hard the ground probably shook everywhere nearby, overlays a global population map to count how many people were exposed to each level of shaking, and then applies what is known about the local building stock and about deaths in past earthquakes in comparable places. Out comes a probability distribution, not a number, a spread. The output is summarized as a color. Green means little expected damage. Yellow means a local response is needed. Orange means a regional response. Red is the top of the scale, and it means a national or international response will be required. Both Venezuelan earthquakes were assigned red. For the magnitude, 7.5 main shock, the system estimated a 23% chance that deaths would fall between 1,000 and 10,000, a 44% chance they would fall between 10,000 and 100,000, and a 30% chance they would exceed 100,000. For the magnitude 7.2, it estimated a 37% chance of 1,000 to 10,000 deaths, a 39% chance of 10,000 to 100,000, and a 13% chance of more than 100,000. Read those figures carefully, because they are easy to misuse. They are not a body count. They are not a prediction that a specific number of people died. They are the system's honest statement of its own uncertainty, published within an hour of the event when nobody knew anything. The most likely single band for the main shock was 10,000 to 100,000 deaths, and the system gave that band less than even odds. The written summary attached to both events said that high casualties and extensive damage were probable, and that the disaster was likely to be widespread. The assessment rested heavily on one input, and it is the input that made red inevitable. The database describing Venezuelan construction records that much of the population lives in structures that perform badly under shaking. The predominant vulnerable types are unreinforced brick masonry and adobe block. Unreinforced means there is no steel inside the walls. Brick and mortar are strong when you press down on them, and weak when you push them sideways. And an earthquake pushes sideways. Adobe is dried earth. It holds a roof up beautifully, and it does not bend at all. Alongside those sit the reinforced concrete apartment buildings of Caracas and the coast, some built to the code adopted after the 1967 earthquake, many built before it, and many built outside any code at all in neighbourhoods that grew faster than the paperwork. A separate alert accompanied the first, this one for economic loss. It was also red. There is a hard thing to say here, and it should be said plainly rather than dressed up. On the evening of the earthquakes, before a single body was recovered, before any government had spoken, a computer in Colorado had already concluded from magnitude, depth, geography, and building type that this was likely to kill people in the tens of thousands. More than 2 weeks later, the confirmed count stands at a fraction of that. Whether the model was wrong or whether the count is incomplete is the central open question of this disaster, and this report will come back to it. First, though, the coast, where the shaking arrived at its worst and where the fewest people had anywhere to run. La Guaira is a state that is mostly cliff. It occupies the strip of land between the northern face of the coastal range and the Caribbean Sea. In places, that strip is 2 miles wide. In places, it is a few hundred yards. The mountain rises behind it to more than 8,000 feet, and the sea drops away in front of it, and everything the state contains is squeezed into the space between. Into that space, Venezuela has put a great deal. The main international airport is there, at Maiquetía. The country's principal seaport is there. So is a continuous ribbon of towns that runs east from Catia la Mar, through Maiquetía and Macuto and Carabaleda, and the neighbourhood of Los Corrales, out toward Naiguatá. Perhaps 400,000 people live along it, many of them work in Caracas, on the other side of the mountain, reached by a highway that climbs through a tunnel. The rupture ran offshore, just to the north, and past the coast in the direction it was already travelling. The towns were in front of the zipper. Reports from the state describe something close to total structural failure across large parts of it. Roughly 80% of buildings in La Guaira are assessed as having collapsed. That figure comes from the damage assessments compiled in the week since, and should be read as a state-level estimate rather than a certified count, because certified counts do not exist yet. What is not in dispute is that in the coastal towns, blocks of mid-rise apartment buildings came down whole. 3 things combined against this coastline, and each is worth putting into plain language. The first is what the towns are built on. Coastal flats are made of loose sediment washed down from the mountains, sand and gravel and silt, sitting on top of the harder rock. Loose sediment does not transmit shaking, it amplifies it. Seismic waves entering soft ground slow down and grow taller, the way a swell rising into shallow water becomes a breaker. The official ground failure assessment for the main shock flagged a significant area of expected liquefaction, with a significant population exposed. Liquefaction is what happens when saturated sand is shaken until the grains lose contact with one another, and the whole deposit briefly behaves as a liquid. Buildings on it sink, tilt, or fall over intact. The second is what the buildings are. 7-story concrete apartment blocks stand along the seafront in Carabaleda and Los Corrales, many of them decades old, some of them built on that sediment, few of them designed for the level of shaking that arrived. The third is that there was nowhere to go. A town 200 yards wide, with a mountain on one side and the sea on the other, has no open ground. When buildings fall in a place like that, they fall onto the only streets there are, and the streets become impassable, and heavy equipment cannot reach the rubble. That last point turned out to be the difference between life and death for a great many people. In the first days, families in Carabaleda stood beside collapsed towers, where relatives were known to be, waiting for a crane. In one case reported by the family, foreign rescue workers who assessed a collapsed 7-story building told them that reaching the lower floors would require lifting 10 large slabs of concrete. Without machinery, that is not work that hands can do. Among the missing on this coast are more than 100 Venezuelans who had arrived at La Guaira only recently, deported from the United States on an immigration flight and housed in a hotel near the port. The hotel collapsed. They have not been accounted for. Over the mountain, in the valley, the capital was learning what its own foundations were made of. Caracas did not collapse. That needs saying first, because the images that travelled fastest came from a handful of catastrophic building failures, and they were not representative of a city of 5 million. What Caracas did was fail in patches, and the pattern of the patches follows the geology of the valley almost exactly. The city sits in a trough about 15 miles long, filled with sediment that has been washing down off the surrounding mountains for a very long time. The depth of that fill is not uniform. Along the northern side of the valley, beneath the districts of Los Palos Grandes and Altamira and Chacao, the sediment is deepest, several hundred feet of it. Toward the south, the bedrock comes closer to the surface. Deep, soft basins do something specific to seismic waves. They trap them. Waves enter, slow down, grow in amplitude, and then bounce between the basin walls instead of passing through. So the shaking at the surface lasts longer and rings at particular frequencies. Every basin has its own note. Buildings also have a note, set by their height and stiffness. When a building's note matches the ground's note, the building takes energy from the shaking with brutal efficiency, and the swaying grows with each cycle. Engineers call it resonance. Anyone who has pushed a child on a swing has used it. In the deep northern sediment of Caracas, the ground rings at a period that corresponds, roughly, to buildings of 10 to 15 stories. The city already knew this. In 1967, a far smaller and more distant earthquake destroyed 4 tall buildings in Los Palos Grandes and left the low-rise districts nearby largely intact. That result was studied for decades. It is one of the foundational case histories in earthquake engineering, and the Venezuelan building code was rewritten because of it. This time, the shaking arrived from the west, at the end of a 110-mile rupture that had been gathering energy the entire way, and it lasted far longer than in 1967. In Chacao municipality alone, on the deep northern sediment, 58 people were confirmed dead, and 26 were pulled from the rubble alive. Rescue teams worked collapsed structures in Palos Grandes. Buildings that stayed standing were often unusable, their columns cracked at the base and their walls sheared. More than 28,000 Venezuelans have since been told that their homes are in danger of collapse, which means they are structurally unsound and cannot be reoccupied. Among the dead was the president of the Caracas Metro, who died some days afterward of injuries sustained that evening. The subway system he ran carries most of the city. The immediate aftermath in the capital had a texture that survivors described consistently. Power failed across large districts, water pressure dropped, cell networks stayed up but were unusable under the cool volume. Dust from pulverized concrete hung in the valley air, and the people who lived in tall buildings that had not fallen went outside and stood in the street, because nobody could tell them whether their building was safe, and because the ground kept moving. It has kept moving since. In the second week, a magnitude 4.6 aftershock struck under the coast north of Carabaleda in the middle of a working day, and apartment buildings in Chacao emptied again into the street. One resident, evacuating, told a reporter that she did not know when there would be a moment of true peace. That is the honest condition of the capital. Not destroyed, not safe, standing on ground that has not finished settling, in buildings nobody has had time to check. Meanwhile, out on the coast, a clock had been running since the first shock, and everyone involved knew exactly how much time was on it. The rule of thumb in disaster medicine is 72 hours. Most people who are pulled alive from collapsed buildings are pulled out inside the first 3 days. After that, the survival curve falls away steeply, mostly because of dehydration, crush injuries, and the cold that comes at night, even in a hot country. The rule is not a law, it is a statistical description of past rescues, and it exists to help commanders decide where to send the limited machinery they have. The response to this earthquake began, as it always does, with neighbours. For the first hours there was nobody else. Rescue services in La Guaira were themselves buried, their stations damaged, their staff searching for their own families. What functioned in the coastal towns was ordinary people, working the rubble of their own streets, lifting slabs with car jacks and rebar and their hands. In Los Corrales, one of the worst-hit neighbourhoods, volunteers pulled bodies out of collapsed apartment blocks for days before any organised team arrived. Reporters who reached the area found residents digging with their fingers. International help came, and it came at scale. Within the first week, more than 2,000 rescue workers from 27 countries were operating in Venezuela, organised into more than 40 teams, with over 160 search dogs. Teams came from Argentina, Jordan, Chile, Spain, and the United States, among many others. 2 Florida task forces and a Los Angeles County Fire Department team worked the collapsed buildings of La Guaira. Because signs of life kept coming from under the rubble, the teams did not stop at 72 hours. They kept working the pile. On the second day, a woman named Diana Patiño and her son Juan David were recovered from a collapsed apartment building after more than 30 hours. The boy was 18 days old. Rescuers had located them and could not immediately reach them, so they threaded a pipe down through the debris and passed water to the infant through a straw. A 12-year-old girl, Fabiana Blanco, spent 30 hours in the debris with injuries to her legs and back. She is recovering on crutches. On the 8th day, a father of 2 named Hernán Alberto Gil Flores was lifted out of the ruins of a shopping mall in Catia la Mar after a rescue operation that lasted 120 hours. He had been trapped since the evening of the earthquakes. Rescuers carried him out on a stretcher through a crowd that applauded. These recoveries are extraordinary, and they are also rare, and the arithmetic underneath them is grim. Roughly 2 weeks on, search and rescue has transitioned to recovery. That word is doing a great deal of work. It means the teams are no longer looking for survivors. They are retrieving the dead. At the beginning of the second week, the United Nations Humanitarian Coordinator in Venezuela reported that the agency and the Venezuelan government had jointly agreed to procure 10,000 body bags. He said the death toll would keep growing as the search continued and as assessment reached places nobody had been able to visit. That procurement figure was not a forecast of the final toll and was never presented as one. It was a logistics decision, made under uncertainty, by people who had read the same probability distribution the automated system had published on the first night, and who had decided not to be caught short. It was also, at that moment, roughly 5 times the number of deaths the government had confirmed. That gap has not closed. It has become the thing everyone is arguing about. Here is what the confirmed death toll has done. 2 days after the earthquakes, the Venezuelan government reported 235 dead and about 4,300 injured. 5 days after, the President of the National Assembly announced 1,719 dead, just over 5,000 injured, and nearly 16,000 people left without housing. A week after, the figure was 2,295 dead and more than 11,200 injured. By the following day, it was 2,595. 10 days out, 2,954. 12 days out, 3,535, with 16,740 injured and nearly 18,000 without homes. The day after that, 3,685. Now, at just past 2 weeks, the confirmed figure stands at 3,811 dead and 16,740 injured. Each of those numbers is confirmed. Each was superseded within days. The line has climbed steadily, in increments of 1 to 600, and it has not flattened. Against that line stand 2 other kinds of number. The first is the automated estimate published on the first night, which put the most likely band at 10,000 to 100,000 deaths. The second is what the United Nations has said aloud. At the end of the first week, its humanitarian officials stated that they were preparing for as many as 10,000 deaths. The head of the United States Geological Survey's assessment stands unrevised. Based on the level of devastation observed, the final toll is most likely to fall between 10,000 and 100,000. Venezuelan opposition outlets have reported discrepancies between different official tallies released on the same days by different arms of the government. Independent verification of the state's figures is not currently possible in a country where foreign press access is restricted and where communications in parts of the disaster zone failed and have not fully returned. 3 explanations are on the table, and they are not exclusive. The first is arithmetic. Confirmed deaths everywhere in the world mean bodies recovered and counted. Roughly 60,000 buildings are damaged or destroyed. Heavy machinery has reached a fraction of them. People under those buildings are not yet dead in any official ledger. The New York Times reported this directly, describing a hidden toll under the rubble that will take weeks to emerge. The second is health. The emergency response team leader for the International Rescue Committee has warned that the number of deaths will continue to rise after the world's attention moves elsewhere, because there is no health system standing. Deaths from untreated crush injury, from infection, from kidney failure after prolonged compression do not appear in the earthquakes column unless someone chooses to put them there. The third possibility is that the official count is being managed. That is an accusation rather than an established fact, and this report will treat it as such. What can be stated is that the government has not published a figure for the missing, that satellite estimates of destroyed buildings exceed the government's own count by a factor of nearly 70, and that public anger at the state's numbers is now visible on the streets of Caracas. There is a fourth possibility, and honesty requires it be included. The models may be too pessimistic. The holiday put people in their homes rather than in schools and offices, and in a country where the housing is poor and the offices are better built, that ought to have raised the toll rather than lowered it. But the models are calibrated on global averages, and the coastal towns, though densely built, are not enormous. Nobody knows. That is the true answer, and it will be the true answer for months. What is known is that a very large number of people have not been found. No official figure for the missing has been published by the Venezuelan government. Asked directly, officials have said the number is in the thousands. Everyone else who is counted has arrived somewhere else entirely. At the beginning of the second week, the acting president stated that the country had recorded more than 800 aftershocks and that search efforts were continuing, while the International Rescue Committee said that nearly 50,000 people remained unaccounted for, children among them. The United Nations Under Secretary General for Humanitarian Affairs has put the figure above 50,000. Because the state was not counting, Venezuelans built their own registries. One database called Venezuela Reporter was set up by a Venezuelan living in Miami and estimated the missing in the tens of thousands. A second site, Desaparecidos Terremoto Venezuela, recorded about 31,000 names as of the beginning of this week. A third, Venezuela Looks for You, listed 18,100 as of 2 days ago. Venezuelan government sources cited by outside encyclopedias have referenced a figure of roughly 41,000. These lists do not agree, and the reasons they disagree are worth understanding, because the disagreement is not evidence that any of them is dishonest. A crowdsourced missing persons list is a list of reports, not of people. The same grandmother reported by a granddaughter in Spain and a grandson in Florida and a neighbour in Carabaleda may appear 3 times. People flee. A family that walked out of Los Corrales and reached relatives inland is found, and nobody thinks to remove the entry. Others were never in the disaster zone at all and simply cannot be reached, because the telephone network in parts of La Guaira has not recovered. Pulling in the other direction is undercounting. A household that died together has nobody left to report it. Migrants, of whom Venezuela has a great many passing through, are often known to no one locally. The plain conclusion is that the true number of missing is unknown, that it is very large, and that the crowdsourced totals are upper bounds containing duplicates rather than confirmed counts of the dead. 2 specific facts anchor the scale. Initial casualty reporting from remote areas was scarce, which officials attributed to failed communications, and which Venezuelan journalists have attributed in part to a media blackout. and more than 100 people who arrived at La Guaira aboard an immigration deportation flight from the United States, and who were housed together at a hotel near the port, went missing when the hotel collapsed. They arrived in the country and the ground opened underneath them. What the missing turn into, in time, is the identification problem. Authorities have opened an emergency cemetery about an hour inland from La Guaira. Refrigerated trucks carry the recovered dead out of the coastal towns. Each burial is being carried out individually rather than in a mass grave, with a white cross and a numbered identification code, specifically so that the graves can be reopened and the dead named later. Close to 300 bodies currently lie unclaimed. Relatives in La Guaira have publicly complained of irregularities in how recovered bodies have been handled. At a makeshift morgue, one woman identified her relative by a ring. The missing are the reason the death toll cannot be trusted as a measure of the disaster in either direction. It is a count of what has been reached. The same problem, in a form that can be measured from orbit, applies to the buildings. Venezuelan authorities reported that more than 850 buildings had been damaged or had collapsed. Two researchers at Oregon State University, Scher and Jamin van den Hoek, ran an analysis of satellite radar data and estimated that 58,870 buildings were likely damaged or destroyed. The gap between those two numbers is nearly 70-1, and it is not a case of one side lying and one side telling the truth. They are measuring different things in different ways, and the difference is instructive. The government's figure is a count of inspected structures. Somebody went to a building, looked at it, and wrote it down. In a country whose civil protection agencies were themselves buried, where the coastal highway is blocked, where much of the housing is on hillsides, and where the state has been short of fuel and vehicles for a decade, that count reflects how many buildings could be reached and inspected in 2 weeks. It is a real number, and it is an undercount by construction. The satellite figure comes from a method called damage proxy mapping, and it works like this. Radar satellites bounce microwaves off the ground and record not just how much comes back, but the precise phase of the returning wave. Passing over the same ground twice, weeks apart, a satellite sees a pattern of returns that is nearly identical if the surface has not changed. The similarity between two passes is called coherence. When a building collapses, the surface texture changes completely, and coherence in that pixel drops. The technique cannot tell you a building is destroyed. It tells you the ground there does not look the way it did. That is why the researchers say likely damaged or destroyed. It is a probabilistic map. It also cannot be blocked by a landslide, refused entry at a checkpoint, or slowed by a fuel shortage. It sees the whole coast at once. The United Nations Development Programme built its own assessment from seismic modelling, satellite imagery, and population data. Its range for direct physical damage runs from $4.5 to nearly $9 billion, with a central estimate near $6.5 billion. That is about 6% of the entire annual economic output of Venezuela erased in 90 seconds. Reconstruction will cost considerably more than the damage, as it always does. The building stock explains the numbers. Across this region, a great deal of housing is unreinforced brick masonry and adobe block. A wall of bricks held together with mortar, and nothing else will carry the weight of a roof for a century. Push it sideways, and the mortar joints open, the wall hinges, and the roof comes down onto whatever is beneath it. Adobe behaves the same way, and weighs more. Reinforcement means steel bars running through the masonry, tying the walls to each other and to the foundation, so that the building sways as one object instead of coming apart into its pieces. It is not exotic technology. It is rebar, and it costs money, and it is invisible once the plaster is on, which is precisely why it is the first thing left out. The consequence is now a housing emergency. Close to 18,000 people have lost their homes outright. More than 28,000 have been told their houses are at risk of collapse and cannot be lived in. Around 12,800 people are sheltering in about 80 sites across Caracas and La Guaira, and the government has now stood up 82 temporary camps. Behind all of this sits a number that predates the earthquake entirely. Before the ground moved, roughly 8 million Venezuelans were already assessed as needing humanitarian assistance. The satellites that counted the buildings were also looking at the ground itself. What they found near the airport at Maiquetía was not damage, it was the fault. The satellites had been overhead the whole time. Radar imaging satellites pass over northern Venezuela on a fixed schedule, indifferent to what is happening below them. They had photographed the coast weeks before the earthquake. They photographed it again within days afterward. Comparing the two sets of images is how modern geodesy learns what a fault actually did, as opposed to what the seismic waves suggest it did. There are two ways to run the comparison, and both were used here. The first is called interferometric synthetic aperture radar, which is a long name for a simple idea. The satellite sends down a microwave pulse and measures the phase of the wave that returns. If the ground has moved even a fraction of an inch toward or away from the satellite between two passes, the returning wave comes back slightly out of step with the earlier one. Combining the two images produces a pattern of coloured fringes, each fringe representing a fixed increment of ground displacement. Reading the fringes is reading the deformation. The second method is cruder and, in this case, more revealing. It tracks features. Take the image from before and the image from after. Divide both into small tiles, and for each tile find where it moved to. Roads, field boundaries, riverbeds, the corners of buildings. If the ground on one side of a fault slid 20 feet east, the tiles on that side show up 20 feet east. The preliminary results are published, and they are being revised. What they show near Caracas is more than 10 feet of near-surface offset. Sit with that number for a moment. Not 10 feet of shaking. 10 feet of permanent, one-way displacement. The ground on one side of the break now stands 10 feet along the fault from where it stood on the 23rd of June. It will never go back. Everything crossing that line was severed. This was not what the first model suggested. In the hours after the earthquakes, the working picture was of a rupture that began onshore in Yaracuy State and then ran offshore onto the San Sebastian Fault, doing most of its work under the sea, where it could break as far and as violently as it liked without anyone being standing on it. That is a consequential difference. An offshore rupture shakes a coastline. An onshore rupture tears it. The geology allows for it. The San Sebastian Fault runs mostly offshore, north of the coastal range, but it has a known onshore segment, and that segment passes near Simón Bolívar International Airport at Maiquetía, where it goes by the local name of the Bruscas Fault. It is the one place along 100 miles of coast where the plate boundary comes up out of the water and crosses dry land, and it happens to cross it directly beneath the country's principal air link to the outside world, in the middle of a densely built coastal strip, 12 miles from a capital city of 5 million people. The intense band of aftershocks that satellites and seismometers have both mapped lies in the same zone. Two independent groups modelled the slip and disagreed about its size. The United States Geological Survey model puts peak slip on the fault at roughly 6.5 feet, in the middle of the rupture. The Italian National Institute of Geophysics and Vulcanology model puts peak slip at close to 12 feet, near Caracas. The satellite offset measurements sit closer to the second answer. The reason for the disagreement is honest, and it is geometric. Most of the fault is underwater. Radar cannot measure the displacement of the seafloor. Satellites see the deformation of the land beside the break and infer the rest. And where the land is a narrow strip and the fault runs offshore a mile from it, the inference is thin. Where the fault comes ashore, the measurement is direct. That is why the onshore segment matters far beyond its length. It is the only place the earthquake left a signature that can be read without a model in between. There is a practical consequence, and it is not academic. Ground that has been offset 10 feet has not merely moved, it has been shattered along the line of movement for tens of feet on either side. Water mains crossing it are gone, sewer lines are gone, buried power and telecommunications cable is gone, the airport apron, the port, the coastal highway, all of it lies within a few miles of the break. The measurements are preliminary, they will be updated. What they have established already is that the second half of this rupture was not a distant offshore event felt from a safe remove. It came ashore, and there is a growing argument that it was never two earthquakes to begin with. Every account so far in this report has described two earthquakes. That is what the United States Geological Survey catalogue says, and its catalogue is the standard reference. A magnitude 7.2 at 4 minutes and 33 seconds past 10, coordinated universal time. A magnitude 7.5, 39 seconds later. A different method, applied by a different group, produces a different answer. The technique is called source time function analysis. Rather than picking out the arrival times of individual wave phases at individual seismometers, it works backward from the shape of the whole recorded signal to reconstruct how much moment, meaning how much work, the source released at each instant. It does not begin by assuming how many earthquakes there were. It just asks the seismic record how the energy came out over time. Run on a normal earthquake, it produces a single pulse. A rise, a peak, a fall over 10 or 20 seconds. Run on the Venezuelan sequence by the GEOSCOPE Observatory at the Institute of Earth Physics of Paris. Using an automated method called SCARDEC, it produced something else. The analysis models the entire moment release, beginning at 32 seconds past 4 minutes past 10, as one prolonged and uninterrupted rupture process, containing several strong pulses spread across about 2 minutes. Under that reading, the events are not two earthquakes but one, developing in a cascade, and the total moment corresponds to a magnitude of 7.8. That is a substantially larger earthquake than the one in the headlines. Magnitude 7.8 against magnitude 7.5 is roughly a tripling of energy, and it is not a correction in the sense of somebody having made an arithmetic mistake. Both readings are defensible descriptions of the same physical event. The disagreement is real, and it comes from a genuine ambiguity about what the word earthquake means. If a fault begins to slip, and the slipping stops in one place while continuing in another, and 39 seconds later a neighbouring fault begins to slip because the first one loaded it, is that one event or two? The seismic waves do not care. The rock does not care. The distinction is a bookkeeping choice, and different bookkeeping serves different purposes. For emergency response, 2 events is the more useful description. 2 ruptures, 2 epicenters, 2 shaking maps, 2 probability estimates. For understanding what happened to the crust, 1 continuous cascade may be closer to the truth. A break that started deep in the eastern Bocano system, transferred on to the San Sebastian, ran 110 miles east along the coast, and released its energy in several distinct surges over 2 minutes, is a single unbroken chain of cause and effect. Calling the first surge a foreshock and the second a main shock imposes a boundary that the fault itself may never have observed. The Britannica account, following the seismological consensus, describes the first event as having activated the second, on separate faults nestled within the same system, with the shaking from the first raising stress on the second until the rock gave way. That is the 2 earthquake picture with a causal link drawn between them. The single rupture picture simply refuses to draw the boundary in the first place. 39 seconds is the number on which the whole question turns. A gap of 39 seconds is enormous for a fault, which moves at 2 miles a second and can unzip 100 miles in under a minute. It is nothing at all for a person standing in a stairwell. Both readings should be reported because both are held by serious people who have looked at the same data. The official catalogue says 2 events, 7.2 and 7.5. An independent analysis says 1 event, 7.8. Neither has been withdrawn. For anyone who is underneath it, the argument is beside the point. The ground moved for something over 100 seconds, and then it kept moving in smaller ways, and it has not entirely stopped. The count depends on who is counting. The United States Geological Survey, whose global network is tuned to detect earthquakes anywhere on the planet above roughly magnitude 4.5, reported 8 aftershocks across the rupture zone in the first days, ranging from magnitude 4.3 to 4.8. The Venezuelan Foundation for Seismological Research, operating a dense national network with stations directly above the fault, detected more than 600 events in the same window, ranging from magnitude 1.4 up to 5. By the second week, the acting president stated the country had recorded more than 860 aftershocks. Those 3 numbers are all correct. A national network hears the small ones. A global network only hears the ones large enough to be heard from another continent. The difference between 8 and 600 is not a dispute. It is a description of instruments. Aftershocks are not mysterious. A large earthquake relieves stress along the fault it broke, but it adds stress to every piece of rock nearby because the crust is continuous, and pulling one part of it into a new position bends everything adjacent. Those newly loaded patches then fail in their turn, and the biggest of them load their neighbours, and the process runs down the scale until it dies out. The dying out follows a rule that has held for well over a century, called Maury's law. The rate of aftershocks falls off in proportion to 1 over the time since the main shock. In plain terms, if a sequence produces a certain number of aftershocks on the first day, it will produce about half that number on the second day, a third on the third day, and a 10th on the 10th day. The decay is slow. Tails are long, and magnitude 7.5 leaves a fault that is measurably noisier than normal for years. A second rule from the Swedish seismologist Marcus Both holds that the largest aftershock in a sequence tends to be about 1.25 magnitude units smaller than the main shock. For a 7.5, that predicts a largest aftershock somewhere around magnitude 6.2. Nothing near that has occurred. The largest aftershocks so far have been in the range of magnitude 4.4 to 5.2, with the largest events clustering east of Caracas, in the zone where the rupture ended. Independent analysts describe the sequence as running on the lower side of an average sequence. That is not reassurance, it cuts the other way. Both's rule describes what sequences usually do. A sequence that has not produced its expected largest aftershock has not necessarily escaped it. The published forecast states plainly that an aftershock above magnitude 5 is likely within the next year, and that a much larger aftershock, magnitude 7 or above, is unlikely but possible. Unlikely but possible is the honest phrasing, and it should be left exactly as it stands. Location matters more than magnitude for anyone living through this. Shaking depends on distance, and a moderate aftershock directly beneath a town produces stronger ground motion there than the main shock did from 100 miles away. 2 days after the earthquakes, an aftershock brought down a bridge in La Guaira. 5 days after, a magnitude 5.2 struck in the early hours of the morning. A week and a half after, a magnitude 4.6 struck at a depth of 6 miles, with its epicenter north of Caracas, and residents of Chacao, 20 miles away over the mountain, evacuated their apartment buildings into the street. None of those aftershocks would ordinarily damage a sound building. That is the point. The buildings are not sound. 60,000 structures are cracked, and a cracked structure can be finished by shaking that a healthy one would shrug off. The standard advice, which is also the official advice, is to stay out of and away from damaged buildings, and to have a plan for the next tremor before it arrives rather than during it. The staff at the National Seismological Observatory in eastern Caracas have been recording all of this from inside the damage. The instruments have also been picking up something that is not the fault. On the slopes above the coast, the mountain has begun to come down. The coastal range rises from sea level to more than 8,000 feet in a horizontal distance of about 7 miles. Slopes of that steepness exist because tropical rain strips the soil off them as fast as it forms, leaving a thin skin of weathered rock and vegetation clinging to the surface at the maximum angle friction will allow. They are, at all times, on the edge of failing. Shaking removes the margin. When seismic waves pass through a hillside, they briefly reduce the friction, holding the soil to the rock beneath it, and for a fraction of a second, gravity has the argument to itself. Some slopes fail immediately, others do not fail, but arrive at the far side of the earthquake, weaker than they went in, with cracks opened, root systems torn, and the internal structure of the soil broken down. The ground failure product issued with the main shock predicted that landslides would be significant in number and in spatial extent. The survey then ordered up satellite imagery and began the slow work of mapping what had actually happened, dividing the coastal range into grid squares about 1.5 miles on a side and classifying each one from what could be seen through the cloud cover. The map that emerged shows widespread landsliding across the slopes above the coast, along with an assessment of which roads are obstructed and where. 4 towns are named specifically as sitting downstream of observed widespread landslide activity and therefore at increased risk: Naiguata, Carabaleda, Macuto, Puerto Cruz. Every one of them is on the coastal strip that took the worst of the shaking. The mechanism that threatens them is not the landslide itself. It is what a landslide becomes when it meets water. Loose rock and soil sitting in a steep stream channel is stable while it is dry. Add enough rain and the mass saturates, loses whatever internal strength it had, and begins to move downhill as a single slurry of mud, boulders, and water. This is a debris flow. It moves at the speed of a car. It carries rocks the size of trucks because, in a fluid that dents a truck-sized rock, is nearly weightless. It follows the stream channel, which is exactly where the roads and the houses are, because the stream channel is the flat ground. And when it reaches the coastal plain, it spreads out and stops, burying whatever is there under many feet of rock. The survey's assessment of the areas it reviewed did not identify any landslide dams, which are the additional hazard of a slide blocking a river until the impounded water breaks through it in a single surge. It notes carefully that landslide dams could exist in areas that were not reviewed or that were hidden by cloud. The timescale in the assessment is the part that deserves attention. Landslides can still occur for days to weeks. Slopes stay more prone to failure for months to years. Areas downstream of the observed slides may be at increased risk of debris flows for several years. Aftershocks can trigger new failures. Heavy rainfall can trigger new failures. Removing debris can remobilize a slide that had come to rest. Venezuela's rainy season runs from roughly May to November. The earthquake struck in the middle of it. Within a week, the United Nations humanitarian coordinator was reporting that a tropical wave was threatening heavy rain across the affected area and describing the operating environment as high risk. 60,000 damaged buildings sit at the bottom of a shattered mountain, in the rain, in a country whose emergency services are already committed. This coastline has run this experiment before, and the results are on record. In the middle of December 1999, a stalled weather system parked itself over the Venezuelan coastal range and rained. It rained for days. The mountains above what was then Vargas State, now La Guaira, received an extraordinary quantity of water in a very short time, on slopes already saturated by an unusually wet fortnight. The soil on the upper slopes lost its grip. Thousands of individual landslides started high in the range and fed themselves into the steep stream channels that drain north to the sea. What came down those channels were debris flows. They swept through the coastal towns at night. They carried boulders larger than houses and deposited them on beaches where some of them still sit, and where geologists later measured them to estimate how fast the flows had been moving. Whole neighbourhoods, built across the mouths of the channels, on the fans of rock and mud that previous debris flows had laid down over the centuries, were removed. Carabaleda was destroyed. Los Corrales was destroyed. Macuto and Naiguata were hit. These are the same towns named in the current landslide assessment. The death toll from that storm has never been established. Published estimates range from a few thousand to tens of thousands. Nobody knows for the same reason nobody knows now, which is that the missing were buried under material that was never dug out. The event is remembered in Venezuela as the Vargas tragedy, and it is the deadliest natural disaster in the country's modern history. The United States Geological Survey studied it in detail and published its findings in an open file report on the debris flow and flooding hazards of the 1999 storm, along with recommendations for how to reduce the risk. The report is cited twice in the footnotes of the landslide assessment the survey issued for this earthquake. When the agency wrote that populated areas downstream may be at risk, and named Naiguata, Carabaleda, Macuto, and Puerto Cruz, it added a note pointing out that some of these areas were affected by deadly debris flows in 1999. That reference is doing something specific. It is saying that the hazard is not hypothetical, that the channels above these towns have carried lethal debris flows within living memory, and that the mechanism which produced them is now more likely than it was a month ago, rather than less. Here is the difference between then and now, and it runs in the wrong direction. In 1999, the rain came first and did all the work, arriving on slopes that were merely wet. This time the shaking has come first, and it has already broken the slopes, opened cracks, loosened blocks, and delivered an enormous volume of fresh loose material directly into the stream channels, where it now sits, waiting. The rain has not arrived yet in the quantity of 1999. The season for it is only half over. There is a further complication. 27 years ago, the debris flows fell on towns that were standing. If a comparable rainfall arrives in the coming months, it will fall on towns that are already rubble, on a population living in temporary camps and on beaches, with the coastal highway obstructed and the evacuation routes uncertain, and with an emergency apparatus that has been working without rest for 3 weeks. The standard advice for people downstream of steep, recently shaken ground is not complicated. Watch for heavy or sustained rain, and treat it as a warning rather than a nuisance. Move uphill and away from stream channels, not along them. Listen for the sound, which survivors of these events consistently describe as a low rumble, and leave early, because a debris flow travels faster than a person can walk. Water is already the central problem on this coast, though not yet in that form. The water system has failed. That is the finding of the International Rescue Committee, reported at the end of the first week, and it is the single most consequential piece of information in this entire account of the aftermath. Many survivors do not have guaranteed access to safe drinking water. Why it failed is easy to explain and hard to fix. Water arrives in a city through buried pipe. Buried pipe is rigid, it is jointed, and it runs across the ground rather than being suspended above it. When the ground moves 10 feet along a fault, every pipe crossing the fault shears. When the ground liquefies, pipes float upward or sink. When shaking passes through a distribution network, the joints work loose. The pumping stations lose electricity. The treatment plants lose electricity, and, in a country that has been short of power and chemicals and spare parts for a decade, do not simply switch back on when it returns. A city can survive without power for weeks. It cannot survive without water for days. Along the coast of La Guaira, weeks after the earthquakes, families are washing on the beach. The Associated Press has described people improvising showers and toilets on the sand because the sanitation infrastructure of the towns behind them no longer exists. Around 12,800 people are living in about 80 shelter sites across Caracas and La Guaira, and the government has now established 82 temporary camps. At a shelter in La Guaira, residents told a visiting reporter that what they needed were portable toilets and help reorganizing the site to reduce overcrowding, because they understood exactly where crowding and open sanitation led. Where they lead is diarrheal disease. The mechanism is unglamorous and reliably lethal. Human waste with nowhere to go contaminates the standing water and the surfaces people touch. Without soap and without clean water for washing, the contamination reaches food and mouths. In a crowded camp, the cycle takes days to establish. Children and the elderly dehydrate fastest. The International Medical Corps reported, a week in, that the majority of people in the hardest hit areas were without food, drinking water, shelter, or access to basic health care. The scale of need is difficult to hold in the head. The International Organization for Migration estimates that as many as 6.8 million people may be affected by this disaster to the point of requiring shelter, water, sanitation, health care, or other relief. The United Nations Children's Fund reported that 680,000 children are among 1.8 million people needing humanitarian assistance as a direct result of the earthquakes, set against a prior baseline of roughly 8 million Venezuelans already assessed as needing humanitarian assistance before any of this happened. There is a smaller problem inside the water problem, and it has begun to attract attention from Venezuelan environmental specialists. The rubble has to go somewhere. Some of it is being put into the Caribbean Sea. Specialists interviewed by the outlet Efecto Cocuyo have warned that concrete, gypsum, metals, and paint dumped offshore will alter water quality, smother coral, and disrupt the fisheries that coastal communities depend on. They note that Venezuela is party to international agreements prohibiting the dumping of waste at sea, and that the country lacks a specific legal framework for managing earthquake debris. Their recommendation is that debris be sorted, recycled, and held at temporary collection sites, in line with international disaster management practice. For a fishing town that has lost its houses, its water, and its hospital, the state of the reef in 5 years is not the most pressing question. It will become one. The advice given by every relief agency working the coast is the ordinary advice, and it is worth stating because it is what actually saves lives in this phase. Drink water that has been boiled, treated, or supplied in sealed containers. Wash hands with soap before eating and after using a toilet. Keep human waste away from where people sleep and eat. Get diarrhea in a child treated early with oral rehydration salts rather than waiting. The hospitals that would otherwise catch these cases are themselves among the casualties. Consider what an earthquake does to a health system. It creates, in 90 seconds, an enormous number of severely injured people. More than 16,700 are confirmed injured in Venezuela, and that count, like the death toll, is a count of people who reach somewhere that recorded them. At the same moment, it damages or destroys the buildings those people must be treated in. Hospitals and schools are among the tens of thousands of structures the satellite analysis identifies as damaged or destroyed, and it kills the staff. Clínica Alpha, the only private clinic still operating in La Guaira, lost 6 of its doctors and 5 other staff members. Its owner, Massimiliano Luca, has kept it running on donated supplies and donated medicine with the people who are left. The Venezuelan health system was in poor condition before the 24th of June, after years of underinvestment, shortages of medicines, and the departure of a large fraction of the country's doctors. It is now, in the words of the International Medical Corps, at breaking point. Hospitals are overwhelmed. Some are operating far beyond capacity. Health workers are exhausted, and many are missing. The clinical picture is now shifting, and the shift is the thing to understand. The first phase of an earthquake's medical burden is trauma. Crush injuries, fractures, head wounds, amputations, all arriving at once. That phase has largely passed, though its consequences have not, because crush injury damages muscle, and dying muscle releases substances that destroy the kidneys, and kidney failure after prolonged compression is treatable only with dialysis, which requires clean water, reliable power, and functioning machines. The second phase is infection, and it has begun. Eugenio Cova, who heads the trauma unit at the Hospital José Gregorio Hernández in Caracas, has described it directly. The complex trauma will continue to arrive, he said, but it is now being complicated by infection. What he anticipates are the infections carried by patients who have been exposed to the conditions of the disaster for the longest time. Those conditions are open wounds, dressed in the field, contaminated by dust and sewage, in people who have been living outdoors in tropical heat and humidity for 2 weeks. Tetanus, wound sepsis, gas gangrene in crush injuries. The wounds that were survivable when they were fresh become lethal after 10 days without antibiotics. Running alongside it is the disease of the camps. Al Jazeera's correspondent, reporting from a shelter site in La Guaira, described widespread reports of diarrhea and other illnesses among the population there. Raxmara Godoy, a doctor volunteering in La Guaira, has said that health conditions are worsening and that the risk of infectious disease flaring across the disaster zone will keep increasing. The United Nations has issued a formal warning about the spread of infectious disease. The emergency response team leader for the International Rescue Committee, Rafael Velázquez, has made the point that follows from all of this, and it is the argument for why the eventual death toll may be far above the confirmed count. The decisive factor, he says, is Venezuela's ability to care for its injured and sick survivors. When international attention moves on, the numbers of affected, injured, and dead will continue to rise because there is no health system standing. Deaths that occur that way, 6 weeks out, in a shelter, from an infected leg or from dysentery, are not usually recorded as earthquake deaths anywhere in the world. They are earthquake deaths. The people already dead present a problem of a different kind, and it is one Venezuela is meeting with unusual care. About an hour inland from La Guaira, heavy machinery is excavating new ground. Authorities have opened an emergency cemetery there for the dead of the 24th of June, because the existing cemeteries of the coast cannot absorb them. Refrigerated trucks carry the recovered bodies out of the disaster zone and up the road. Forensic workers meet them. At La Esperanza Cemetery in La Guaira, witnesses have watched coffins arrive by truck, while machines dug trenches in open ground marked out with white crosses. Almost 300 of the dead currently lie unclaimed. What is happening at the new cemetery deserves to be described precisely, because it is being done correctly, and that is not always the case in disasters of this size. Each burial is being carried out individually, not in a mass grave, but in a single plot with a single body in it, marked by a white cross bearing an identification code. The purpose of the code is explicit. It allows the grave to be reopened and the person in it to be named at a later date, when a relative comes forward, when dental records surface, when someone brings a photograph or describes a ring. Mass graves are what happens when a state panics. They are dug for reasons of public health that turn out, when examined, to be largely mistaken. Bodies after a natural disaster do not generally cause epidemics, because the people who died were not, as a rule, carrying epidemic disease when the building fell on them. The living in the camps are the disease risk, not the dead in the rubble. What mass burial reliably does is make identification impossible forever, and identification is not sentimentality. Without a death certificate, a widow cannot inherit, a parent cannot claim, a child cannot be enrolled, an estate cannot be settled, and a family cannot stop searching. So the codes and the individual plots matter, and they represent a decision made under enormous pressure by people who could have chosen otherwise. The work of identification is being done in improvised morgues under conditions that would be recognizable to any forensic pathologist working after a major earthquake. Bodies recovered from concrete after 2 weeks in the heat are frequently not identifiable by sight. Identification proceeds by what the person carried and wore. A France 24 report from a makeshift morgue carried the account of a woman who identified her relative by recognizing her ring. Not everything has gone well. Relatives in La Guaira have publicly denounced irregularities in the handling of bodies recovered there. Those complaints have been reported by Venezuelan outlets and have not, to date, been independently adjudicated. They should be recorded as allegations and left there. Meanwhile, the dead accumulate names in the ordinary way: 8 Chinese nationals, 4 Chileans, 2 Spaniards, the president of the Caracas metro, dead of his injuries some days after, a young Venezuelan rock musician, one of the country's more promising, killed in a collapse, more than 100 deportees from an immigration flight in a hotel by the port, unaccounted for, and the vigils. In the second week, hundreds of people gathered in Caracas and in Maracaibo. At the Central University of Caracas, they lit white candles and set them on the ground, arranging them into the outline of the country. That gathering was grief. The gatherings that followed a few days later were not only grief. Public anger in Venezuela is now directed at the state's response, and it has moved from the shelters into the streets of the capital. The country entered this disaster in an unusual political condition. The government is led by an acting president, Delcy Rodriguez, in what outside observers describe as an interim administration, in a country that was already contending with a prolonged political and economic crisis before the ground moved. The president of the National Assembly, Jorge Rodriguez, has been the official voice reading out the casualty figures on state television. The complaint against them is specific rather than general. Critics say the first hours after the earthquakes passed without organised official rescue, that heavy equipment was not brought to La Guaira when it was still capable of saving lives, and that the people who dug were neighbours. Carolina Jimenez, president of the Washington office on Latin America, put the criticism in one line. In any other country, she said, the first responder should be the state. In Venezuela, the state has been the last responder. The government's account differs. The acting president has stated the death toll and injury figures publicly and repeatedly, has reported that search and rescue continued past the point at which it is ordinarily abandoned, and has angrily defended the response against criticism. She established a commission to assess damage to housing. In the third week, she created a new military unit to oversee emergency and disaster management, a permanent body to handle what the existing agencies had struggled with. An analysis published by the Venezuelan outlet TalCual argues that the earthquakes have exposed the limits of the interim government, particularly in its official communications. On Wednesday of this week, labour unions and civil society groups marched through Caracas. They carried signs demanding elections. They gathered outside the headquarters of the country's intelligence agency, where they also demanded the release of political prisoners, and the march later continued toward a hotel where officials from the United States are reported to be staying. Union leaders said that the emergency should not be used to suspend public demonstrations, and criticised what they described as delays in the initial disaster response. The politics here are contested, and this report will not adjudicate them. What can be said without taking a side is that the disaster arrived in a country with weak state capacity, that a great deal of the rescue was performed by civilians and by foreign teams, that the government's own count of damaged buildings is a small fraction of what satellites see, that no official figure for the missing has been published, and that these facts are now inseparable from the argument over who should govern. There is one more thing that ought to be said plainly, because it is easily lost. Reporting from the disaster zone is difficult. Communications failed in parts of La Guaira and have not fully returned, and Venezuelan journalists have alleged a media blackout. Initial casualty reports from remote areas were scarce for both reasons at once, and the two are hard to disentangle from the outside. Every number in this report about the dead, the injured, and the homeless originates with a Venezuelan government announcement. Every number about buildings, about the missing, and about the probable eventual toll originates with someone else. That divergence is not proof of anything. It is a fact about the evidence, and the honest thing is to name it rather than pretend the record is cleaner than it is. What has arrived from outside the country, meanwhile, has arrived in quantity. The international response has been large, fast, and in the case of the search teams, decisive. Within the first week, more than 2,000 rescue workers from 27 countries were operating inside Venezuela, in more than 40 teams, with over 160 search dogs. They came from Argentina, Chile, Jordan, Spain, and the United States, among many others. The dogs matter more than they sound. A trained dog clears a collapsed building faster than 100 people can, and locates living people rather than voids. Those teams have now largely gone home. Members of 2 Florida task forces returned to Miami this week, after more than a week working the rubble. Their departure is the formal end of the rescue phase. The United States government has committed more than $386 million in humanitarian assistance. This week it announced a logistics partnership intended to remove the bottleneck that follows every large disaster, which is not money and not goods, but the last few hundred miles between an airport and a person. Amazon will fully fund 7 cargo flights each week, aircraft and fuel, forming a humanitarian air bridge from the United States into Venezuela, working alongside the State Department, the aviation charity Airlink, the United Nations Logistics Cluster, and the World Food Programme. The stated purpose is to prevent airport congestion and speed medical supplies, shelter materials, and other essential aid to organisations on the ground. Private and diaspora efforts have been substantial. Global Empowerment Mission, working with the group I Love Venezuela, has committed to moving more than $50 million in humanitarian supplies through the first 75 days by cargo aircraft, ocean freight, and trucking, establishing distribution hubs with local partners. Goya Foods donated £100,000 of food. Across South Florida, home to a large Venezuelan population, collection drives have been running in Doral, Miramar, and Poinciana, staffed by volunteers working overnight to load pallets. The United Nations has been coordinating the humanitarian operation from inside the country, procuring body bags, running the shelter and water response with the government, and issuing regular situation reports. 2 cautions belong here, and they are the same 2 cautions that follow every large disaster. The first is the funding curve. Emergency aid arrives at speed and then stops. The needs of a country that has lost 60,000 buildings do not stop. They change shape, from search dogs to cement, from field hospitals to dialysis machines, from bottled water to a rebuilt treatment plant, and the money for the second kind is far harder to raise than the money for the first. The second is that aid entering Venezuela enters a contested political space. It arrives from a United States government that is deeply entangled in the country's internal politics, into a state whose legitimacy is being challenged in the street, at a moment when demonstrators are marching to the hotel where American officials are staying. Every pallet of rice is also an argument. This is not a reason to withhold aid. It is a reason to understand why aid moves slowly here, even when there is a great deal of it. Rafael Velasquez of the International Rescue Committee has named the thing that will determine the final toll, and it is neither the fault, nor the government, nor the aid convoys. It is whether the injured and the sick receive care after the world stops watching. The watching has already started to fade. The rebuilding has not started at all, and it will have to be done on ground that is still moving. Reconstruction has technically begun. In the third week, work started at Brisas de Maiquetía, a state housing complex in La Guaira. The scale of what must follow is set by the numbers already given. Around 59,000 buildings damaged or destroyed. More than 28,000 households in homes that may collapse. Nearly 18,000 people with no home at all. Direct physical damage estimated by the United Nations Development Programme at somewhere between $4.5 and nearly $9 billion, most likely near 6.5, which is about 6% of the country's annual economic output. Full reconstruction will cost several times the damage. The question is not whether it will be rebuilt. It is what gets built, and where, and by what standard. Venezuela has an earthquake building code. It was substantially rewritten after the 1967 Caracas earthquake, and it is not a bad code. The problem in northern Venezuela has never been the existence of the code. It has been enforcement, the cost of steel, and the enormous quantity of housing that went up outside any permitting process at all, on hillsides, incrementally, one story at a time, as families could afford them. The engineering required is not exotic, reinforced masonry, meaning steel bars run through the walls and tied to the foundation. Confining columns and beams around every panel of brickwork, continuous ties from the roof to the ground so that a building moves as one object. Foundations sized for the soil beneath them rather than for the soil someone assumed. On liquefiable coastal sediment, ground improvement, or piles down to something solid. On the deep basin sediment of northern Caracas, height limits, or damping for the mid-rise buildings that resonate with that ground. Each of these adds cost, and each of them is invisible once the plaster goes on. Two constraints will shape what actually happens. The first is where. Rebuilding the coastal towns exactly where they stood means rebuilding them at the mouths of stream channels that carry debris flows, on sediment that liquefies, on a strip of land the plate boundary passes directly beneath. The alternative is relocation, which no population accepts willingly and no government executes well. The Vargas experience after 1999 is instructive, and it is not encouraging, because much of what was destroyed was rebuilt in place. The second is the rubble. 60,000 buildings produce an amount of debris that is genuinely hard to imagine, and some of it is being dumped into the Caribbean over the objections of environmental specialists who point out that Venezuela has signed international agreements against it and has no legal framework for handling it otherwise. Debris that is sorted and recycled becomes aggregate for the concrete that rebuilds the town. Debris in the sea is gone and takes the fishery with it. Underneath all of this sits the geology, which has an opinion. The Boconó Fault last ruptured in 1812. At the plate motion rate of roughly 0.4 of an inch a year, it has since accumulated a slip deficit that published assessments judged capable of producing an earthquake between magnitude 7.0 and 7.6. The June rupture appears to have started within the eastern end of the Boconó system before transferring onto the San Sebastian. Whether it discharged the deficit on the main Andayan strand of the Boconó, or merely relieved its eastern tip while leaving the rest loaded, is not yet known. Large earthquakes reduce stress on the fault they break and increase it on the faults nearby. Which of those two things has happened along the Boconó is, at present, an open scientific question rather than a settled one. The El Pilar fault, carrying the same plate motion east toward Trinidad, has been affected too. A geologist in Trinidad and Tobago, examining ground uplift there, has argued publicly that the aftershock sequence has consequences for that country and that it should be paying attention. Whatever gets built on this coast over the next decade will be built on a boundary that moves 0.4 of an inch every year, and does not care what is standing on it. Here, plainly, is what is known. On the evening of the 24th of June, 2 large earthquakes struck northern Venezuela 39 seconds apart, of magnitude 7.2 and magnitude 7.5 at shallow depth near the town of Umare in Yaracuy State. The rupture ran east for about 110 miles along the boundary between the Caribbean and South American plates, gathering its energy as it went, and delivered it to the coastal state of La Guaira and to Caracas. It was the strongest earthquake in Venezuela in 126 years. There was no damaging tsunami. 3,811 people are confirmed dead. 16,740 are confirmed injured. Around 18,000 have lost their homes. Roughly 59,000 buildings are damaged or destroyed, including hospitals and schools. The water systems in the worst hit areas have failed. Here is what is not known. How many people are missing? Estimates from independent registries and from the United Nations range from 18,000 to more than 50,000. They contain duplicates, and the government has published no figure. How many people died? The confirmed count has risen every few days and has not flattened. The United States Geological Survey's assessment, unrevised, places the most likely final total between 10,000 and 100,000. That estimate could be badly wrong. It has not yet been shown to be wrong, whether it was 1 earthquake or 2. The official catalogue records 2 events. An independent analysis from the Institute of Earth Physics of Paris models a single cascading rupture of magnitude 7.8. Both readings stand. How much the ground moved and exactly where the fault came ashore. Preliminary satellite measurements show more than 10 feet of near-surface offset near Caracas. Models disagree about peak slip by a factor of 2. The measurements will be revised. And here is what to watch. The rain. Venezuela's wet season runs to November, and the slopes above Naiguatá, Carabaleda, Macuto, and Puerto Cruz are loaded with fresh landslide debris sitting in stream channels that have carried lethal debris flows before, within living memory. Heavy or sustained rainfall on those slopes is the next hazard, and it is the one most likely to add significantly to the toll. The aftershocks. Above magnitude 5 is likely within the year. Magnitude 7 or above is unlikely and possible. 60,000 cracked buildings will not respond to shaking the way sound ones do. The sick. Infection is now the rising cause of death in the disaster zone, and it will keep rising while there is no clean water, no sanitation, and no hospital system to speak of. This is the number that grows quietly after the cameras leave, and the count itself. Every few days it moves. Watch whether it flattens, and watch whether anyone publishes a figure for the missing. For the people on that coast, the earthquake is not something that happened 2 weeks ago. It is the condition they are living in. The ground under Maiquetía has moved 10 feet and will stay there. The mountain above Carabaleda is broken, and it is raining. 300 people lie in numbered graves waiting for someone to come and say their names. The next report will follow the rain.